Space isn't just the final frontier. It may soon be the next frontier for the internet itself. Imagine a future where internet exchanges don't just happen in data centers scattered across the globe, but actually occur above our heads in orbit. Sounds futuristic? That's exactly what DE-CIX is setting the stage for with their bold SpaceIX initiative. But here's where the discussion gets really interesting. DE-CIX, already a global leader in internet interconnection, recently unveiled its ambitious plans to take its proven internet exchange model beyond Earth's surface. The goal, to establish seamless interconnection between satellite constellations whizzing through low Earth orbit, LEO. These orbital IX points would work hand in hand with ground-based networks, shaping the infrastructure for what could become a truly planetary and even space-based internet. Most people know DE-CIX for its global ecosystem, linking over 4,000 networks at more than 60 locations worldwide. Now, leveraging its decades of experience, the company wants to apply the very same interconnection principles that have succeeded on Earth to networks in outer space. As CEO Ivo Ivanov puts it, wherever networks are created, interconnection should follow. An example of this new chapter unfolds through DE-CIX's involvement in the European Space Agency's Ophelias project. Here, DE-CIX collaborates with the German Aerospace Center, DLR, on pioneering laser-based satellite communications. Unlike traditional radio waves, these optical links offer lightning-fast data transfer, but introduce new technical hurdles, such as how to manage disruptions from our atmospheric conditions. This is the part that most people miss. As satellites move to cutting-edge tech, engineers must invent brand-new protocols to ensure reliable, high-speed connections. While Ophelias is primarily about linking satellites back down to Earth, SpaceIX goes a step further. It aspires to interconnect the satellites themselves, effectively creating a mesh of communication in orbit that echoes the interconnected land-based internet most of us rely on every day. We're not talking theory alone. In August 2025, DE-CIX India made history as the first internet exchange in the region to onboard Starlink, SpaceX's high-profile LEO satellite broadband system. This milestone signals a new era where terrestrial and orbital networks increasingly blend, particularly benefiting industries and applications where ultra-low latency, almost instantaneous data travel, makes all the difference. Think real-time disaster monitoring, autonomous transport, or global video calls that actually feel global. Astonishingly, the space economy is set to skyrocket to an estimated $1.8 trillion by 2035, fueled by everything from global broadband and the Internet of Things, IoT, to artificial intelligence, AI, and space-based remote sensing. Picture data centers not just as server-filled warehouses in distant lands, but as orbital nodes circling the planet. British astronaut Tim Peake, well known for his work aboard the International Space Station, has floated the idea of orbital data centers that could slash latency for critical applications and boost computing power right from space. In his current role as strategic advisor to Axiom Space, Peake is helping spotlight the UK's part in the next wave of space innovation. And here's a potential game-changer ripe for debate. Could the advantages of limitless solar energy and thermal rejection in space actually make orbital data centers as affordable as their Earth-bound counterparts by 2035? Peake suggests this cost parity can soon become reality, especially as advances allow data storage, processing, and data storage, and artificial intelligence to function directly in or from space. On that note, Axiom Space is racing ahead with plans to deploy not one, but two orbital data center ODC nodes to LEO before the end of 2025. These ODCs aren't just futuristic concepts. They'll soon provide secure, scalable, cloud-enabled services, everything from storing data to processing it with AI and machine learning, directly to satellites, constellations, and whatever next-generation spacecraft needs a digital boost. Earlier this year, Axiom even launched AX-DCU-1, a prototype space data processing unit, in partnership with Red Hat, further blurring the boundary between terrestrial tech and space-powered solutions. But the big question remains: how rapidly will these advances change the shape of digital communications, and what new ethical or technical dilemmas might emerge as we build a truly off-planet internet? Will orbital data centers really deliver on their promise of green, unlimited capacity? Or are we moving too fast into uncharted territory? Sound off below. Do you see orbital interconnection as an unstoppable leap forward? Or do you have reservations about this great digital migration to space? We want to hear your thoughts, both enthusiastic and skeptical.